All right, tonight we will be working on this problem related to work and power. Just a short review. When we say work, a force causes the object to change its position, or we call it displacement, right? We have positive work, negative work, zero work, stuff like that. And then if we will be defining power, power is just the rate of work. Okay, unit will be joules per second, and our unit of work, since it's you know something to do with it has something to do with energy, so the unit will be joules. Okay, so let's work on this problem. We have a man having 75 kilograms riding an elevator in a shopping mall. The elevator moves the man at a constant velocity from the ground level to the floor above, which has a vertical height of 4.6 meters. Then what is the work done on the man by the elevator and then by the gravitational force? And if the elevator can lift 1,000 kilograms at a distance of 100 meters at a velocity of 4 meters per second, what's going to be the power the elevator exerts during this trip? So letter C, we will be working on power. We will first answer A, and then B and C, and then we have that's the last item. Okay, for letter A, work done on the man by elevator. Okay, so our formula to get the work, if you could still recall, work is equal to force times displacement. Actually, we have cosine theta, but in this case, we will just neglect about it. Okay, but we have to do the sign convention. We have positive work and then negative work. Positive work, just a short review. We say positive work, the force and displacement direction is the same, or going to the left. The force is going to the left, the object's displacement is going to the left, or upward force, displacement is upward, or on the other hand, downward and then downward. That's a positive work. We also have the so-called negative work. Negative work, it is when force and displacement is opposite. Let's say friction force is going to the left, and then the displacement of the object is going to the right. So that's going to be negative work. Or the force of gravity is going downward as it used to be, and the object is being thrown upward. All right, so that's a negative work. Okay, so in this case, we will try to visualize what's going on. Work done by elevator to the man. Okay, so if we will try to visualize it, the elevator, this is the just don't mind with my object here, it's the elevator. And then the elevator, according to the problem, there's a man inside the elevator, a 75-kilogram man riding on an elevator in a shop, and then the elevator moves the man at a constant velocity upward, right? And that's gonna be 4.6 meter from the ground level. Okay, so this elevator moves 4.6 meter from the ground level, and look at the displacement of the elevator here with the man inside. It's still going upward, so that's a displacement, and this is going to be the direction of the force of our elevator. So if that's the case, our answer must be positive because it's a positive work. Now, in the problem, you couldn't see any force there. Look at the given. Given is 75 kilogram mass. That's gonna be the mass. We have a height It's there. It's 4.6 meters. And then aside from that, the velocity is also provided. Velocity, it's constant, by the way. It's constant. It's provided here in item C, right? 4 meter per second. I will put it there. Now, if that's the case, no force in our given, right? No force. And remember, unit of force is Newton or uppercase N. You couldn't see any unit of newtons in the problem. What will you do? Now, this is the game changer. You have to, okay, I will use the other color. You will have to look or focus on the mass of the object. If there will be no force given in our problem, but you have a mass, so we can convert it into force. So how to do it? It's easy as this. Remember, and please take note that force is equal to the mass times gravity. Gravity on Earth, of course, or mass times gravity, it is known as weight. So force is equivalent to weight. You have the mass, it's 75 kilogram, and you know the value of gravity. Gravity is always 9.8 meter per second squared on Earth. We will just multiply that one, and we will get the force. All right. So how to do it? Let's get the force. Force is equal to mass times gravity. So the mass of the man inside the elevator, that's that's very clear in our system. So that's 75 kilogram multiplied by the value of gravity, 9.8 meter per second squared on Earth. So our force in this case, 75 times 9.8, it's gonna be 735. 735. The unit of force is Newton. So we already have the value of force. Okay, I will put it there. Force is 735 newtons, so that I will free some of the space here. So we finally have the value of force. Okay, so force, our F here, it's gonna be this value, 735 Newton. And the displacement of the elevator with the man inside is 4.6. It's in the problem, 4.6. So we will multiply it by 4.6 meters. So 735 times 4.6, the product will be 3,381. The unit is Newton meter, or we can write this unit as joule, right? Newton meter or joule. To avoid confusion, you can also just write it as joule. Okay? So this is going to be the work done by the elevator to the man, or the elevator does a positive work of 3,381 joules to the man. Okay, our answer is 3,381 joules. That's a positive work. Now, in letter B, we will need to find gravity, or the work done by gravity to the man. Okay, let's say it's our elevator here with a man inside, and then this elevator goes up 4.6 meters from the ground level. And then since we're dealing with gravity this time, the gravity's direction is going downwards. So in this case, displacement displacement of our elevator with a man inside is going upward. Very clear, right? Upward. But our gravity is going downward. So if that's the case, if it goes downward, the force direction of gravity is downward, displacement of the object is still upward. As the elevator goes up, different direction, our answer should have negative. Okay? Since we're not using cosine here, uh, we will automatically put negative to our answer because it's a negative work. Informs us that that the force and displacement, the directions are opposite to each other. So we have negative work. In this case, they're opposite, so we have a negative answer here. Okay, how are we going to do it? So it's still the same thing. Our force, we don't have newtons here, we have 45. So again, to get the force, it's just mass times gravity. So 75 kilogram multiplied by 9.8 meter per second squared. That's constant on Earth. So 75 times 9.8, you will have 735 kilogram meter per second squared. We can conveniently write it as Newton, unit of force. Force is gonna be 735 newtons. That's the value of force. So formula to get the work, but this time the work is, done by gravity. So again, we will just put it directly negative here so that we will have a negative answer. So uh, force times displacement. So it's negative. The force is 735 Newton. And so we have displacement of 4.6 meter. Okay. So the answer 735. We did it already. We calculated it already. So the answer will be 3381. But this time it's going to be negative because uh, the the direction, negative Newton meter or joule, right? The direction of the force due to gravity is downward while displacement of our elevator is going up. Opposite direction, the answer will be negative. So we have negative 3381 joules. Okay. Now we have letter C, the last problem. So I will gonna erase first everything here. Letter C, it's a conditional. If the elevator can lift up 1,000 kilograms at a distance of 100 meters at a velocity of 4 meters per second, what is the average power the elevator exerts during this trip? Remember, power, just a short review about power. So power, we will use letter P as our variable symbol. Power is just work over time. Okay, so work over time, we can also write it as force times displacement over time. Okay, so in this case, I will erase some of the variables here. We will change it. The needed given in our letter C problem, we have the mass. That's 1,000 kilogram. If the elevator can lift a mass of that heavy, then the distance of our, this is a displacement of our elevator, will be 100 meters. And then we have velocity 4 meters per second. And then we need to find the power. Okay, when we want to get the work, we should have to get the force and then the displacement. In this case, no Newton in our letter C problem. no force is being mentioned, but we have mass. Again, when there will be no force given in the problem, focus on the mass. And remember, force is equal to mass times gravity. And our mass is 1,000 kilogram multiplied by 9.8 meter per second squared. 9.8, that's the value of gravity. So 9.8 times 1,000, the answer will gonna be 9,800 kilogram meter per second squared, or we can conveniently write it as Newton. So our force, I will put it here, force or F is just 9,800 Newton. Next thing to do, instead of putting work here to make the calculation way easier, we will replace work with its formula, this one. Okay, I will change the formula. Again, work over time. But in order for us to substitute the units well, so we will just change this W here, or work, since work is equal to FD, or force displacement, so we can be able to change the variable W as F and D. Okay, so we already have the value of force. We calculated it seconds ago, 9,800 newtons. And displacement, it will move at a distance of 100 meters. So 9,800 times 100, you will have 980,000 Newton meter. Okay, Newton meter or joule, right? So we already have the work here. This is just still the work, right? This one. And what about the time? We have a variable of time here. How are we going to get the time or to calculate the time? I will just write it here. Work is 980,000 joules. Okay. But our next problem here, we already have the value of work, that's 980,000 Newton meter, or let's say joules, and divided by the time. How are we going to calculate the time? Okay, so let's go back to our given. We have our velocity. We also have our displacement. So remember, when we have velocity without direction, it will become speed, and then distance here, or displacement. So we can get the time by using the speed formula. Speed formula is speed is equal to distance over time. We have time here. Okay, and to get the time, we will just derive it by cross multiplying the variables. Understood, we have s over 1 here. So we have the speed times the time. It's speed times time equals displacement times 1. That's displacement. To isolate the time, we will divide both equation by s. So we can cancel s, and we have time is equal to distance over s. Okay, so we can get the time now. Distance or displacement, that's 100 meters. And then we have speed or velocity, that's 4 meters per second. Okay, we can cancel now units here, meters and meters, so we have seconds left. So that's the unit of time. So we're going there. 100 divided by 4, that's going to be 25 seconds. So this is going to be the time, 25 seconds. So we can substitute now 25 to the variable of time. The time is 25 seconds. So 980,000 divided by 25 seconds, the answer is 390 39,200 joules per second. This is gonna be the power, the average power of the elevator exerts during the trip. Okay, that's 39,200 joules per second, or we can write it as 39200 watts, unit of power. Joules per second could also be written as watt, or the symbol will be W. Don't be confused it with work. Okay, that's it, and I hope you learned something from this problem. If you're new to this channel, you can like, comment something, and then you can subscribe, of course. Thank you so much, and see you in my next video.